the beginning of Chapter 7, Section 1. We're dealing with zero and negative exponents. And so you're all pretty familiar with exponents. 4 to the third power is just 4 times 4 times 4. And so 4 times 4 is 16, and then 16 times 4 is 64. So that's, exponents when the exponent is a positive whole number. And now we're going to be dealing with exponents that are either 0 or negative. So we got to figure out how to treat those. So here are a couple of rules that you should put in your notes. These are 0 and negative exponents. So anytime that your exponent, I shouldn't say any time, as long as we call this the base, as long as the base is non-zero, if the exponent is 0, your answer is 1. So therefore, 4 to the 0 power is 1, negative 3 to the 0 power is 1, and even a decimal, 5.14 to the 0 power is 1. Okay, so almost anything to the 0 power is 1. If you have a non-zero number a as your base, and the exponent is negative, what you have to do is you have to take the reciprocal and change the exponent to a positive. So here's what we're talking about. If you have 7 to the negative third power, what you do is you flip it, so you put it under 1, and the exponent becomes positive. So now you have 1 over 7 to the third, and then you figure out what is 7 to the third. Here, this would be 1 over negative 5 squared, because before it was negative 5 to the negative second power. So you take the reciprocal of it, change the exponent to a positive. Now, what we were talking about, where this, it has to be a non-zero base. So it makes sense that if you got 3 to the 0 power, it's 1, and 2 to the 0 power, it's 1, and 1 to the 0 power is 1, shouldn't 0 to the 0 power be 1? But what that would do is go against the fact that 0 to the third power is essentially 0 times 0 times 0, which is 0. Right? You can't multiply something times 0 and not get 0. So 0 squared is 0. 0 to the first power is 0. So therefore, 0 to 0 power is 0, you would think, right? And so following both of those patterns, you would think that it should equal either 1 or 0, and you could actually make a case for both of them, but what it actually is undefined. So if you have 0 to the 0 power, it is undefined. So let's do a couple of these real quick. So 9 to the negative 2 power would just be 1 over 9 to the positive 2 power. And then simplify it, you have to, figure out what 9 squared is, and 9 squared is 81. So 9 to the negative 2 power is 1 over 81. Here we have a non-zero base to the 0, so your answer there is 1. Okay. Take a second, pause the video, and try to do each one of these on your own. Okay, here are your answers. So this becomes 1 over 4 to the third. 4 to the third is 64. So 1 over 64. Negative 5 to the 0 power is 1. 3 to the negative 2 power is 1 over 3 squared. Simplify it as 1/9. 6 to the negative 1 is 1 over 6 to the first, which is just 1/6. And negative 4 to the negative 2 is 1 over negative 4 squared. Negative 4 squared is 16. And again, make sure that you're putting the 4 in parentheses if you're doing this in your calculator, because if not, you're going to get 1 over negative 16. Okay. This is not something that you should be relying on your calculator for. Okay, we have to know how to do this by hand. Now, what happens when we get variables involved? Really nothing, except that simplifying means we have to get all positive exponents, okay? So we got to get all positive exponents. So what this actually is like is this is 5 times, I'm going to use just a dot so it doesn't get thought of as an x. 5 times a to the third times b to the negative 2. So if I said just rewrite this part, you would rewrite it as 1 over b squared. So what we now have is 5 times a to the third times 1 over b squared. And if you simplify that, you still have 5 times a to the third, but it's now over b squared. And that is the simplified version. Okay? What happens if it's already on the bottom? You just flip it. So instead of being 1 over x to the negative 5, it is now x to the positive 5 over 1. And you know that you don't have to write the 1 when it's in the denominator, and so it's x to the 5th. Okay, so pause the video, take a second, try some of these on your own. Okay, part A would be 1 over x to the 9th. B would be n to the 3rd over 1, but we're not going to write that. C, only the c to the negative 3 goes on the bottom, so on top it stays 4b over c to the 3rd. The a now goes up top, so it's 2 times a to the 3rd, positive 3rd. And now your n goes on the bottom, so it's 1 over the m squared stays down there, m squared times n to the 5th. And then what happens if you have to plug numbers in for them? Okay, you treat it like normal. So we have 3 times s, which is 2 to the 3rd, times t, which is negative 3 to the negative 2. So what would happen here is this would be 3 times 2 to the 3rd over negative 3 squared. Okay? 2 to the 3rd is 2 times 2, which is 4, times 2 is 8. 3 times 8 is 24. Negative 3 squared is 9. And then you reduce that if you can. 3 goes into both of those, and so you get a final answer of 8/3. Okay, we'll do 2 of these together, so I'll do A and B together with you. So take a second and do those. Okay, so n is negative 2, so that's negative 2 to the negative 4th. W is 5. So what we have is 5 to the 0 power over negative 2 to the 4th. 5 to the 0 is 1, and negative 2 to the 4th is negative 2 times negative 2, which is 4, times negative 2 times negative 2. So negative 2 times negative 2, or sorry, 4 times negative 2 is negative 8 times negative 2, and that becomes 16, so 1/16. And up here, we have negative 2 to the negative 1st over 5 squared. Okay. The negative 2 to the 1st is going to end up being on the bottom, so all that's left up top is a 1. We have negative 2 to the 1st times 5 squared. Negative 2 to the 1st is negative 2. 5 squared is 25, so negative 2 times 25 is negative 50. And then the last one. So now, what if we're talking about bacteria? Bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by this equation, where H is the number of hours after a scientist measures the population size. If h is 0 and h is -3, what does each value of the expression represent in the situation? So if we plug in 0, 1,000 times 2 times 0, so you got 1,000 times 2 to the 0 power is 1, so that's 1,000. What they're asking is, what does that 1,000 represent? That 1,000 represents the number of bacteria, and it says the number of bacteria modeled by the expression where h is the number of hours after a scientist measures the population size. If it's 0 hours after the scientist measures the population size, it's when they start. The number of bacteria when the scientist first measures the population. If we plugged in -3, we have 1,000 times 2 to the -3, right there. So that becomes 1,000 divided by 2 to the third. 2 to the third is 8, so you have 1,000 divided by 8, which turns out to be 125. So what does that 125 represent? 125 is the number of bacteria 3 hours. What's a -3? 3 hours before the scientist first measured. Okay? And so that's where these negative exponents and 0 exponents are going to come into play.